Hey everyone, welcome back to Neural and Wires. So, in today's episode, we're diving into self attention, which is the heart of modern AI models like ChatGPT, and learn to focus on important words in a sentence. We'll break it down step by step, explaining how self attention decides what to focus on, how Softmax helps distribute focus, and why self attention is different from simple averaging, and how scaling affects AI decision making. By the end of this video, you'll have a solid grasp of how transformers learn and process language. So, guys, let's get started. So, step one of fixing softmax weighting, why scaling is needed. So, before we jump into self attention, let's fix a common problem we had in the last video. So, why softmax didn't behave like simple averaging. So guys, when using softmax to distribute weights, it didn't match the uniform averaging because softmax applies an exponential transformation, making some values much bigger than the others. And solution with scaling factor by 100. To fix this, we scale the weights before applying softmax, so making them behave close to uniform weights. So all right, and so this is the results match. Now scaling helps control how much weight softmax assign, preventing extreme values from dominating. So step two, guys, we understand self-attention and how AI pays attention. So now that we fixed softmax, let's take things one step further and introduce self-attention. So it's like imagine you're in classroom and listening to different students speak. If a student you trust speaks, you pay close attention, but if a random student speaks, you pay less attention. So you adjust your focus based on the importance of each speaker. This is exactly what self-attention does. Instead of treating all words equally, it assigns different importance weights to each word. So guys, we're gonna be creating a query K and value matrices in self-attention. Every word in a sentence gets converted into three vectors. So vector type query is like Q, what I'm looking for, and the key K is what information do I contain, and the value, what data should I return if matched. To create these vectors, we use linear transformations, and so we ensure reproducibility with this line of code. And this is batch size, sequence length, and embedding size, also random input data. So we define the self attention components, and so we transform the inputs into keys and carries and values. So bt16 so now every word has its own carry, key, and value representation. Guys, now we calculate the attention scores. Now we compute how much each word should focus on every other word. This is done by multiplying carries with key. So now we have a focus score for every word in the sequence. Now we'll be applying masking to prevent looking ahead. Since we're building a language model, each word should only see past words, not the future words. We enforce this by applying a triangular mask. So we lower triangular mask, and then we mask the future words, and we apply softmax to get probabilities. Now each word only attends to past words, guys, and then we multiply by values. Once we know which words to focus on, we retrieve their information by multiplying with values. So this gives us the final self-attended representation. So step 4, we understand the scaling. So guys, now let's explore why we scale attention scores before softmax without scaling. So torch, softmax, tensor. So this is the output. The probabilities are well distributed. With higher scaling, which is a bad case, so the problem, it collapses to a single one hot value, making the model ignore all but one word. So solution, we scale by like 1 over square t head size. So this keeps us the value balance. So guys, why this is matter? Now that we understand the self-attention, we're one step closer to building transformers like GPT. So recap of what we learned. So softmax needs scaling to behave properly, and self-attention assigns focus dynamically, and query, key, and value help decide what's important, and guys, scaling helps balance attention scores. So if you found this helpful, hit that like button and subscribe to Neural and Wires and comment below. So guys, what is the coolest thing you've learned so far? And in the next video, we'll take this concept to the next level by building a multi-head attention system. All right.